It's 8:30 now. We will start live streaming.
Okay.
So, good morning, good afternoon, and good evening, everyone. Welcome to the Way of Reading. This is a special lecture. I am Tenang, your host tonight. And tonight we're going to tackle a question that is both fundamental and often overlooked in SLA research. Can statistical methods explain language learning? And as you can see, it is our great honor tonight to welcome back a truly towering figure in the field of second language acquisition, Professor James Lantoff. This is Professor Lantoff's second time joining us on the Way of Reading live stream, and we are deeply honored to have him with us again. So although Professor Lantoff needs no introduction at all, but I'll still give some brief introduction just for the sake of inspiration. So Professor Lantoff is a Greer Professor Emeritus in Language Acquisition and Applied Linguistics at the Pennsylvania State University, and currently serves as a distinguished professor at the Center for the Cognitive Science of Language at Beijing Language and Culture University. Over the course of 5 decades, he has been a driving force behind bringing Vygotskian sociocultural theory into second language acquisition research. And he is, in the truest sense, the founder of this entire line of inquiry. So a few numbers to give you a sense of his impact. Over 35,000 citations, listed among Stanford University's world's top 2% scientists, president of the American Association for Applied Linguistics in 2005, and recipient of its Distinguished Scholarship and Service Award in 2016. Now, his landmark publications include the 2000 Sociocultural Theory and Second Language Learning from Oxford University Press. This is the foundational work that brought Vygotsky into SLA. The 2014 Sociocultural Theory and the Pedagogical Imperative in L2 Education, co-authored with Pole, which received the Mildenberg Prize from the Modern Language Association of America, and the 2018 Routledge Handbook of Sociocultural Theory and the Second Language Development, which is the authoritative handbook for the field. Now, he is also the founding editor of the journal Language and Sociocultural Theory and the former co-editor of Applied Linguistics. Most notably and most relevant to our live stream, Professor Lantoff, together with Pone and Ricker, recently published a widely discussed article titled Crisis, and we have read this article together in a live stream last year. This is published in 2025 in Modern Language Journal. This article offers a profound rethinking of the state and the direction of SLA research. Tonight's lecture is very much a continuation of that line of thought. So please join me in giving Professor Lantoff a very warm welcome by clicking on the like button in the live stream. Thank you, Professor Lantoff, for joining us again. Do you have something to say to the audience before we start?
Well, thank you very much, Jen, for inviting me a second time. I'm very pleased to be able to participate. I enjoyed the first session very much.
Thank you.
And I'm looking forward to a nice discussion this time. And as you pointed out, this is a continuation of what we wrote about in the MLJ piece. And we're working on a couple of additional articles, including at some point soon, a position paper on the crisis. But that's going to take a little bit of time. I also want to point out that we have a new volume coming out shortly, sometime this summer, from the University of Toronto Press. It's called, it's an edited volume, which has about 17 chapters on the latest empirical work that's being done on sociocultural theory, both in terms of pedagogy, assessment, and teacher education. and the title is Creating the Conditions for Second Language Acquisition. And it should be out sometime later this summer. So please keep your eye out for that new publication. Thank you very much. I'm looking forward to our conversation.
So thank you, Professor Landorf. Now let me briefly introduce tonight's core questions. So this question, as you can see on the screen, it sounds very technical, but it strikes at the very heart of what research is for. Are we doing research to produce a p-value or to understand how language learning actually happens? On screen, you can see the three sub-questions. Can quantitative research explain the process behind language learning? Why doesn't cause necessarily equal explanation? And what does explanation actually mean in scientific research? These are what we'll be exploring tonight. So here's a plan for tonight. We are currently, after the introduction, at about 8:40, I will give a 20 minutes opening report focusing on a specific technical problem, the misuse of statistical methods in corpus-based text analysis. You can think of my talk as a warm-up or the appetizer before the main dish. So which is a close-up look at some concrete pitfalls in how quantitative methods are applied in practice. So after my appetizer comes the main dish, the real centerpiece of the evening. Professor Landorf will take 40 minutes to examine this question from a much higher vantage point. He's not merely asking, are we using statistics correctly? Now he's asking something more fundamental. Even if we use statistics correctly, can they explain language learning? Does establishing causation amount to scientific explanation? What should explanation actually mean in SOA research? So my reports operate at the level of tools, so problems with the statistical instruments themselves. And Professor Landorf's lecture operates at the level of epistemology, the limits of statistical methods, statistical thinking as such. So the two converge on the same conclusion. We need to rethink the role of a quantitative method in SOA research. Now, we will reserve the final 20 minutes for open discussion, wrapping up at 10 p.m. So now let's begin. The appetizer from me. I hope you enjoyed it the next 1 hour and a half. So here we go. Just a minute. So in my opening report, I want to discuss a long overlooked but critical issue in corpus linguistics, the misuse of statistical method. As you can see on the screen, on the timeline, several scholars have raised this issue over the decades, from Kilgraf first arguing in 1996 that chi-square is inappropriate for corpus data, through to Koplenish's systematic demonstration in 2019. The critique has been made repeatedly, yet remains insufficiently addressed. In the next 20 minutes, I will show from 3 angles why chi-square and log likelihood tests are fundamentally flawed for corpus-based text analysis and what we should do instead. So let me start with 2 scenarios that everyone in this live stream has encountered in their own research. The first scenario, a classic 2x2 contingency table, a survey of 800 people, 120 male smoke, 800 female smoke. The chi-square equals 10.67, and the p-value is 0.1, significant. And the Cremer's V equals 0.12, a small but reasonable effect size. Here, chi-square is used entirely correctly. each observation is an independent person, the sample size is reasonable, and the positive rate is around 25 to 30%. This is exactly the kind of problems chi-square was designed for. Now, please keep this example in mind. We will compare it with the corpus scenario in the next slides. So now the corpus scenario. Now, two corporal, totally 54 million tokens. Okay, just a minute. I need to switch the screen. Sorry. Okay, the target word appears around 36,000 times in corpus A and 23,000 times in corpus B. And the chi-square is very large. It's over 8,000. And p-value is very, very small. It's smaller than 0.0001. Looks extremely significant. But the Krimis V, which is the measurement for effect size, is only 0.012, essentially negligible. So notice the proportion bars. So the chi-square value is 772 times larger than the smoking survey, yet the effect size is 10 times smaller. What does this tell us? Now, this is the most critical slide. Same data, different analytical approach. On the left, we use word, the token itself as unit. So the N is 54 million, and chi-square is over 8,000, highly significant. On the right, we use text as the unit of analysis. It's the same corpus, and it's a marking corpus. I compute the normalized frequency of the target word in each text, then run a t-test, an independent sample t-test, every text per group. So the result is T with 1998 degree of freedom, and T equals 1.863, and p-value is not significant, is 0.103, and coherence D is 0.1. So same data, opposite conclusions. One says there is a highly significant difference, and the other says there's no difference. This is not a statistical trickery. It reveals that word-level chi-square has fundamental problems. So let me walk you through 3 of them. So I group the problem into 3. The first 2, independence, violation, and sparsity, are well documented in the literature. The third, lexical heterogeneity, is the argument from my own paper currently under review, and I also give a brief introduction of that. So here's the first problem. The fundamental premise of the chi-square test is that the observations are mutually independent. Now, the smoking survey satisfies this. Whether a person A smokes has nothing to do with person B. Now, of course, there are also confounding variables. For example, people from of the same profession may be more likely to smoke than other professions. People living in one area may be more likely to smoke in other areas. But as a whole, smoker A and smoker B are largely independent. Corporal are very different. Look at the example on the right. Let me take the verb modify as an example. This verb is very unlikely to appear at the beginning of the sentence. If the sentence begins with an article like the or a, then this verb is also very unlikely to appear following this article. What following the is more likely to be an adjective or a noun, which means each word's probability depends on the preceding context. In one sentence, language is an ordered sequence, not a random sample. So Kilgraf emphasized this point in both 1996 and 2005 with the title of one of his papers, Language is Never, Ever, Ever Random. So treating each token as an independent observation fundamentally violates the test premise. The assumption. Now the second problem, sparsity. Look at the left grid. In a classic chi-square scenario, in the smoking review, 30% of observations are positive. I checked the real data. Even among females, there are about 10% of females who smoke. So the red cells are clearly visible on the left grid. But the right grid shows a corpus scenario. The target word is only 0.016% of the tokens. And this is the norm. This is a very common scenario in corpus analysis. And those are highly frequent tokens are not interesting to researchers. So usually what we're interested in are words that do not appear very frequent in the corpus. So among 800 cells on the screen, you can barely see any red. So this means 99.98% of the information in the 2x2 table comes from the absence, not the presence, comes from the absence of the target word. So the chi-square value is almost entirely driven by the enormous other words cell. It measures not the distributional difference of the target words, but the total token counts difference between corpora. In classical statistics, this is a sparsity problem. When events are extremely rare, the chi-square approximation becomes unreliable. And relatedly, because the corpus is very, very large, nowadays using super large corpora has become a norm. The corpora are usually over 1 billion words, at least 100 million words. That means the N is very, very large. And the chi-square test, both chi-square test and log likelihood are very sensitive to sample size. With a sample size of over 100 million, over a billion, even very small difference can produce significant results. So Kilgrove ran an elegant experiment in 2005. He randomly splits the BNC corpus in half, so that the both half corpora comes from the same corpus. So theoretically, they should be the same in terms of the distribution of the lexical items. So the same corpus randomly divided into two halves. The results, as you can see from the bar chart on the left, shows his real table 1 data from the paper. For the 10 most frequent words, the mean chi-square error terms was 18.8. The expected value is just 0.5. So it should be half-half. A total of 3,418 words were flagged as significant difference. And you can repeat this many, many times and you'll produce similar results. So one corpus randomly split in two, and chi-square found over 3,000 keywords. Why? Because word frequency distribution are inherently uneven. High-frequency words have larger random fluctuation, and the enormous N amplifies these into significant differences. On the right is Coplandish's 2019 finding. So the type 1 error, which means the error to find positive when there actually is negative. The type 1 error rate increased monotonically with corpus size. The larger the corpus, the less reliable chi-square test become. This completely overturns the intuition that more data is always better. That's the very reason why we use larger and larger corpora these days. So the third problem comes from my own paper, and also it has been mentioned in 1973, proposed by Clark in 1973, but strangely, after five decades, it has not been paid enough attention to. But recently, I submitted a paper discussing this scenario, and I will introduce that paper shortly. On the left, so words itself, they are not homogeneous. The frequency difference between the and the albeit is enormous. The words are different in their part of speech distribution, in their register preference, in their collocation patterns. So lumping them together implicitly assume they are interchangeable, particularly in studies that study a group of words. as a category. And I believe you can think of many similar studies in this category, so which they clearly are not. So hidden category structures are not uncommon in lexical studies. When we say, for example, when we say meta-discourse markers, the category contains dozens of different lexical items. So you sum in their frequency, assume these words behave uniformly, but however and nevertheless have a very different register distribution. So Clark pointed this out in 1973. Treating language items as a fixed effect is a fallacy. The correct approach is to include words as a random effect variable in a mixed effect model. So mixed effect model nowadays is very common in questionnaire-based studies and in some other directions of applied linguistics, but they have not been paid sufficient attention in corpus-based text analysis. So let me illustrate with a concrete example using attitude markers. If you are working with EAP or you are working with Yarrow analysis, you must be very familiar with these words or these terms. Meta-discourse is one of the most popular analytical framework in Yarrow analysis in the past 20 years. So researchers along this line, they often conclude that social science used more attitude markers than natural sciences. Now, let's suppose this is true. This is statistically verified. But if we break it down word by word, and the table makes this very clear, you may find that this unequal distribution may be driven by a few words. For example, important and crucial are far more frequent in social science, and they are very, very frequent. They are much more frequent than all the other words. So their frequency alone contributes to the difference. And on the contrary, but unfortunately and surprising, show no difference between the two fields. And the essential, or maybe some other words, will actually show opposite direction. That means they are more frequent in natural sciences. So after aggregation, when you put them together, social sciences does have a higher total frequency, but the difference is entirely driven by just two words, important and crucial. But no, these statistics are a marking number. It's not true. The other items show no difference or even reverse patterns. So the so-called category difference is merely the behavior of a few high frequency, not a distributional property of the entire category. I call this a fallacy of you mistake the category difference by the individual variation. The between variable variation is mistakenly taken as the between group difference. So currently, meta-discourse research generally does not account for this factor. So this is one of the core arguments. So in one of my papers I just submitted recently. But here you might be wondering, these critiques started from 1973. Why are they still being ignored today? So it is not ignored. The current situation is that chi-square and log likelihood remain the most commonly used statistical test in corpus linguistics. Studies published in 2024 to 2026 on meta-discourse, keywords, and learner corpora still rely heavily on them. Now, Greece stated explicitly in 2018 that overuse, underuse studies need to be redone. Yet, new studies in 2024 still follow the same approach. So, I think there are three reasons I summarized on the screen. First, there's a textbook lag. Newly published textbooks still teach chi-square and log likelihood without mentioning their prerequisites. Second, I call it toolpath dependency. Mainstream tools like AntConc, sketch engines, and LangSbox, which are used by many researchers in the field. The default statistical methods they offer is either chi-square or log likelihood. So researchers use whatever the tool provides for them without questioning the statistical premises. Now, 3, disciplinary silos. Critiques by Kilgraf, Koplanish, and others were published in computational or methodological journals that applied linguists may not follow. So the results being that 20 years after Kilgraf 2005 paper, the same statistical errors are still being systematically repeated. This is not individual negligence, I think. It is a disciplinary methodological inertia. So what will be the solution? Now we understand the problem. The core idea is simple. Shift from words to text, and from frequency counting to statistical modeling. So the most fundamental change is a unit of observation. On the left, the word as unit, we produced highly significant results, but with negligible effect size. On the right, text as unit. When n equals 200 text, each carrying author, discipline, and other metadata. So if we use the words as a unit of analysis, actually we just give away all this information because the corpus itself only carry the main variable you want to examine. For example, the disciplinary difference or the different English variety. But the corpus consists of text from different person, and each person have a different background. So using words as a unit of analysis actually ignore all this information. So text by different authors can reasonably be treated as independent, or confounding variables can be controlled in this way. So the second solution I propose, and also proposed by many other researchers, I mentioned it in the previous slides. Once we switch to text as unit, another important dimension becomes visible: dispersion. So two words, they both appear 80 times in total, but their distribution are completely different. Methodology is evenly spread across 20 texts. So the dispersion is close to 1 if measured by DP, a genuine register feature. But in other words, hermeneutic is concentrated in just 2 texts, so merely an individual author's preference. If you only look at total frequency, these 2 words appear identical. But after adding dispersion, and the picture becomes entirely different. This is why text-level analysis matters. It automatically incorporates dispersion in information. And the third solution are some alternative statistical methods. So first, the Wilks-Constant ransom test. So this is actually the non-parametric test for independent t-test. When the assumption of normal distribution is violated in independent t-test, which is very common in corpus analysis, we can use this one, Wilcoxon rank sum test. So this is a very simple and effective test, so recommended by Brechena and Meyerhoff in 2014. I used this test in one of the papers I just sent out last month. Second, we could do some bootstrap test, which means you resample text 10,000 times, construct confidence intervals. No distributional assumptions needed whatsoever. The third alternative is use mixed effect models. Text nested within corpora, authors and words are as random effects. This is particularly useful for word list-based text analysis. So this allows simultaneous control of multiple variables and provides genuine explanatory power because you have controlled for all the variables. In the paper I just mentioned, I submitted last month, I compared the 2 corpora of texts. I compared several corpus of text from different genres, but I controlled for the words. And even after controlling for the words, I still identified genre difference in how these words are used. Now, because I have controlled the word, I have more confidence to claim that this genre difference is real. It's not driven by the word. It's not because of the word distribution itself. It's because of the genre. Number 4, regardless of the text you use, always report effect sizes. Some of the corpora-based text analysis, they don't even report effect sizes. And one of the reasons probably is because the effect size is usually very, very small. So along with log ratio, percent difference, or bias factors, effect size tells you how large the difference is, while the p-value only tells you whether you had large enough data to detect it. So finally, some personal suggestion. To close, I want to share 4 principles with you. First, ask yourself, what is your unit of observation? If it is the token, I probably should reconsider. Second, you check dispersion. Third, shift from frequency thinking to modeling thinking. Does the difference persist after controlling for covariance? Fourth, always remember, words themselves matters. Words themselves are variables. Include words as a random effect in your model. Thank you very much. This is my appetizer. I hope you enjoy it. Then here comes the centerpiece of tonight's lecture. Professor Lanthoff will present his talk at a much higher vantage point. Professor Lanthoff, it's your time now. I will stop sharing my screen so you can share your screen.
Okay.
Just a moment. I can't find the menu. Okay, where does the menu go? Okay. I find it. It's so small. I should stop sharing. Why I can't stop sharing? Okay. I have stopped sharing.
Okay.
So you can share now.
Okay. Can you see it?
Yes.
You see it? Okay. Well, thank you very much. Let me first say that I enjoyed your presentation. And some of what you say, I'm going to say in a slightly different way. Not about the details of the statistics, of course, because I'm not a statistician, I'm not a psychometrician, but some of the ways in which statistics are used in a non-questioning way, I think is problematic for the field in general, not just corpus linguistics.
Yes.
And I'll say a little bit about that. So this presentation is sort of a work in progress. It's something that I and some of my colleagues here at Penn State have been thinking about since we wrote the synergies piece. I think the problem extends not just not in terms of quantitative work, but also in terms of some of the qualitative work that I won't talk about today because I don't have time to talk about that. But I think that's also problematic and doesn't get us at a deep explanation of what's going on in second language acquisition. I want to mention that much of what I'm going to say is based on the writings of this particular person that you see depicted on the slide. His name is Aro Tomala. He's an Estonian psychologist and medical researcher. And if you remember in our Synergies piece, we cite some of his work. He is, I think, one of the most important contemporary interpreters of Vygotsky's writings. And much of what I'm going to say today is based on his way of modernizing, let's say, Vygotsky's thinking that was, written almost more than a century ago. So I want to give him credit. I will cite him from time to time throughout the presentation, but overall, I want to make sure I give him credit for stimulating our thinking and how we've been working on the problem of explanation, causality, and quantification in the field. So one of the first and important distinctions that we need to make is the distinction between methodology and method. This is something that Vygotsky wrote about very early on in his work in trying to develop a unified psychology. And these two terms are used interchangeably within the field, within psychology in general, and within the field of second language acquisition. They're not synonymous within Vygotsky's thinking. So methodology is a cognitive way of, it's the cognition of the researcher. It's not the techniques that we use. So Vygotsky makes a really important distinction between techniques and ways of thinking. And Percy Bridgman, who I cite here, who was one of the people responsible for developing the concept of operationalization within science. He was a physicist working in the 1920s, 30s, and 40s, and he's largely responsible for promoting the concept of operationalization, which, in our view, which is another part of our project, has caused more harm than good within the field of psychology and within the field of second language acquisition. But Bridgman says that scientific methodology, or scientific method, he says, is doing one's damnedest with one's mind, no holds barred. So science is about how you think about the object of interest, right? It begins with that. It doesn't begin with a set of techniques. And I think that's part of the problem that the field is facing. We don't worry about how people think, and there are different ways of thinking, as I'll explain to you as we go along. So the distinction is between methodology as a way of thinking and methods as a set of techniques, okay? So methods questions are, I've listed here at least 3 of them. What is the best method or technique for doing multivariate prediction of group membership, right? The second one is which estimation method is best for fitting a statistical model to the data. And another one is how should the number of factors be determined if you're doing factor analysis, for example. But a methodological question is a very different kind of question. And the methodological question is, are the quantitative methods appropriate for explaining the phenomena in principle? And I think Chen raised this at one point. We tend not to question the statistical techniques that we use to try to ostensibly understand some particular phenomena. Is the phenomena itself, a phenomenon of interest, even measurable? And if it's how do we know it's measurable? There are things that we try to measure in psychology and in SLA without ever proving that in fact they're measurable. Things like emotions, right? There's been a lot of work on emotions using Likert scales, for example. Now, how do we know that Likert scales measure anything, right? The same way that, let's say, a thermometer or a scale measures temperature or weight, or a ruler measures height, right? So how do we know that what we're measuring is in fact measurable? We can throw proficiency in there, for example. How do we know that proficiency is measurable? We just assume that it is without proving that it is. And so, this is a crucial question for how we think about what it is we're trying to understand. Okay, so as I mentioned to you, there are different types of scientific thinking. One of the ones that I think dominates both in psychology and in second language acquisition is what we would call metaphysical linear thinking. And this owes its origins to the writings predominantly of two philosophers, Descartes and David Hume. And Descartes' argument was based on a theological assumption that only God can know what the hidden realities of the universe or of reality are. Only God can know this. Humans cannot know this. Humans can only know what our senses tell us, right? Our sense of sight, our sense of sound, our sense of smell, taste, touch, so on. We can only know what is empirically observable through our senses. David Hume made the same argument, although not based on theology, but he basically said that humans don't have the capacity to delve beneath the surface to reveal the secret powers of reality, right? And those two ways of thinking about reality have had a tremendous impact on the kinds of methods that have been developed in science and in social sciences in particular, and more specifically in psychology and SLA. And they've led to this idea of what we might call linear or efficient causality. If X, then Y. If not X, then not Y, right? And I'm going to say more about that a little bit later. So that kind of thinking has resulted in our thinking in terms of variables and how variables supposedly explain causality. And so I've looked at how Mackey and Gass in their book on research methods define variables. Okay, so the first thing they say is that measurement requires identifying variables. So if you want to measure something, you need a variable to be measured, right? And they define a variable as a characteristic that differs from group to group, person to person, object to object, such as, the L1 of the person, the gender of the person, or persons in terms of groups, age, proficiency, aptitude, attitude, pedagogical treatment, so on and so forth. And you classically know the difference between independent variables, what we believe may be the cause of the results, and dependent variables, what we measure to see effects of the independent variable on it, right? So quantitative analysis then assumes a kind of covariance between observable independent entities, X, and dependent variables, Y, and they're separate and independent from one another, right? That's crucial. So X precedes Y in time is in an asymmetrical relationship, and therefore if X does not occur, Y will not occur, and not vice versa. That is, Y does not cause X, okay? So for example, in physics, what would be considered an efficient cause of a balloon expanding is if you heat the temperature, if you heat the air inside of the balloon expands, right? So you have the independent variable is the heated air, and the dependent variable is the expansion of the balloon. Another one, of course, is smoking causes cancer. Cancer being the dependent variable, smoking being the independent variable, right? The problem, as Tumala points out, is that variables encode information about behaviors, not about psychological processes. So, or any process. So if you just consider the rising temperature inside a balloon causes the balloon to expand, that's not about a process, that's only about a behavior that you obviously can observe, right? And that's what has passed as an explanation based on causality in science, and particularly now in the social sciences. And that's the problem that we have to try to overcome. Okay. But there's another way of thinking, a methodological way of thinking, and that's a systems way of thinking. I'm sure you're all, excuse me, familiar with complex dynamic systems theory. I won't say anything about that. That's a separate conversation to have. But Tumala has proposed, again, based on Vygotsky's work, what he calls structural systemic theory. And that's a dialectical way of thinking, right? And within systemic structural or structural systemic theory, the point is to discover the components of a process, identify the relationships among the components, and describe the qualities of a whole that emerge from the synthesis of the components, right? And largely, you search for internal contradictions as the driving force of change, okay? The concept that was used by Hegel, borrowed by Vygotsky, is what's called Aufhebung. And I'll show you an example of that in a few minutes. So just think about the following. If you want to understand how a watch, a wristwatch works, right? You need to understand the parts, right? The gears and so on. But that's not enough. You need to understand the relationship between the gears and the other components, how they relate to each other. You can't just put it together anyway and get a functioning watch, right? It has to be put together in a particular way, and it has to involve certain materials. You can't build a watch out of a rock, for example. You can't build a watch out of water. You need certain kinds of elements, and they need to be related in a particular way that gives rise to a whole that's more than the components themselves. And I'll show you an example of that when it comes to thinking and cognition and consciousness in a moment. Okay? So that's a systems way of thinking. Now, I'm going to use this example from a study that was done by Rod Ellis back in 2005 to show you the problems with a quantitative approach to causality, okay? So if you're familiar with SLA research, one of the great debates that has been going on for decades is the difference between implicit knowledge, abbreviated as IK, and explicit knowledge, abbreviated as EK, right? Awareness versus intuitive. So we know that native speakers of languages, unless you're a linguist, have a naive understanding of how the language works. They don't have conscious access. Their knowledge is largely intuitive. It's largely implicit. They can't tell you what they know about the language. But the question is, what about second language learners? In particular, late second language learners, right? So Rod Ellis tried to carry out a study in 2005 where he was going to try to use factor analysis to differentiate certain kinds of tests that access either implicit knowledge or explicit knowledge, okay? So he had 6 sort of criteria. Awareness, the idea would be that implicit knowledge, you would not be aware of the knowledge you have. Explicit knowledge, you would be aware of, and you could tell somebody what you know, and so on and so forth. His argument was that implicit knowledge was more systematic than explicit knowledge, right? The kind of knowledge that you might get in a classroom, okay? The idea is, 4 is the crucial point. That is, to be able to use a second language fluently, spontaneously, you need to develop implicit knowledge, right? Otherwise, you can't speak the language fluently or write the language fluently. Explicit knowledge you use, this goes all the way back to Krashen's ideas, you can use it for planning if you have enough time in speaking or in writing, okay? So he carried out a study of different kinds of tests to determine which kinds of tests would access explicit knowledge and which kinds would access implicit knowledge. And so you see that there are 3 tests that he used to measure implicit knowledge: elicited imitation, oral spontaneous production, and a timed grammaticality judgment task. He had 2 kinds of tests that measure explicit knowledge: untimed grammaticality judgment tasks and metalinguistic knowledge tests, where you ask people, can you cite the rule, or can you pick the right rule from a choice of various options from among a choice of various options of what the rule might be underlying a particular feature of the language. And his exploratory factor analysis loaded on 2 factors: the elicited imitation, oral production, and timed grammaticality judgment loaded on implicit knowledge, and the untimed grammaticality judgment and the metalinguistic task loaded on untimed. So he thought he had a really neat separation. If you want to access implicit knowledge, you use this particular set of tests, and if you want to access explicit knowledge, use another set of tests. But the problem is the following. The Kaiser and his colleagues pointed out that the same test scores that loaded on implicit knowledge could have emerged from automatic processing of explicit knowledge, right? So how do you know that a grammaticality judgment task that's timed, or an explicit or an elicited imitation task, actually is tapping implicit knowledge, when in fact it could be tapping automatic explicit knowledge, right? In other words, the factor analysis can't get at the underlying process, right? And Michel Paradis, who's a neurolinguist, made a similar argument based on the 2 memory systems in our brain: procedural memory and declarative memory, right? And he pointed out, it's presumably procedural memory underlies implicit knowledge, and declarative memory underlies explicit knowledge, right? And the 2 systems are not connected. So you can't convert declarative knowledge into procedural knowledge. Explicit knowledge can't become implicit. Okay. And he pointed out that second language acquisition is not governed by the same system that's responsible for L1 acquisition. In other words, L1 acquisition when you're a child is governed by your procedural system, but that system, as you age, starts to decline. And Michael Ullman, who's also a neurolinguist, makes a similar argument, okay? So Paradis actually makes the argument that most second language learning is done through the declarative memory system, right? So it's a different process. The problem becomes, as I highlight at the bottom of the page, that in a 2021 article where Ellis goes through all of these tests again, looking at the research that's been done on each of these tests, and he says most tests are unable to distinguish implicit knowledge processed automatically from explicit knowledge processed quickly. That is, quantitative measurement in terms of factor analysis cannot distinguish whether someone is using implicit knowledge or explicit knowledge, right? In other words, it can't get at the underlying process. It can't tell you how the watch is made. It can't have, because, and this is the problem, right? Externally similar behaviors can emerge from different underlying mental processes. So you could have what looks like some speaker using implicit knowledge and another speaker using explicit knowledge doing exactly the same thing, right? Scoring the same thing on a test, for example. We often assume that people who score the same on a test are engaged in the same process, right? So, for example, someone who expresses rage at something happening to them one person could express rage through a conscious decision, and another person might express it through impulse. But how do you know that? You can't, through quantitative analysis, you can't get at that distinction. Louis Thurston, who was a psychometrician of the 1930s, who was largely responsible for promoting, although he didn't develop factor analysis, that was developed by Pearson, says that factor analysis can only express covariation between appearances and not the mechanisms that underlie behaviors. So, rising temperature causes the balloon to expand. Yes, factor analysis can tell you that. Smoking causes cancer, it can tell you that, but it can't tell you why the balloon expands when air is heated. It can't get at the process. The process being that the balloon expands because the mean kinetic energy of the molecules increases and the collective impact within the container thus assumes greater force. That's the explanation. But factor analysis can't get at that explanation. That's the crux of the problem. Okay? Now, Tumala has argued that structural systemic theory has a different way of thinking about causality. It's thinking about causality as a process, and the system changing, the elements changing, the relationship between the elements changing, and creating a completely different kind of whole. All right? And he says that psychology before World War II was very much focused on processes and understanding processes, and for some reason that's unexplainable, after World War II, it lost sight of this of this way of doing psychology. And it shifted over to a quantitative, and this might be due to the dominance of behaviorism, but we can't be certain of that, right? But before World War II, particularly in continental European philosophy, the focus was on the process, and being on the process, what mattered was individuals, not groups. So one of the problems with quantitative analysis is it studies groups, and then what it finds for the group, it imposes on individuals. And it's quite possible that no individual in the group uses the same kind of process that emerges when you do a group-based analysis. Okay? That's part of the problem. Okay? So the question then becomes, how do you establish the components of the system? How do you get at the process? Okay? Now, Vygotsky worked out a series of experiments for doing that, what he called the instrumental method, or the developmental experimental method. I don't have time to go into that in great detail. But what you can do is you can observe whether by changing one of the elements, either putting it in or taking it out, or changing the relationship among the elements of a process, the process itself changes, right? So one of the ways you can do that is you can, let's say, take out something like, Vygotsky argued that one of the crucial aspects of development of mind was the emergence of private speech, okay? If you take private speech out of the process of development of a child, you prevent the child from using private speech, and that can happen either through some kind of brain damage, a defect at birth, where the child can't produce language. You don't get a normal human brain. There's an element that's missing, okay? Now, it turns out that one of Vygotsky's followers, Peter Galperin, did a study in the school system in Moscow back in the 1930s and 40s and 50s, where they took out the use of private speech in the learning of second languages, in the learning of math, in the learning of history. They prevented children from using private speech, okay? And one of the things that happened, okay, let me show you. One of the things that happened was that the children could not learn what they were supposed to learn. So one of the elements was taken out of the process, which tells you that the process depends heavily on private speech, on language. Okay? So the system that Tumala proposes is that you add new elements into a structure, right? Or you eject elements from a structure, you change the relationship between the elements, or the system itself begins to deteriorate, as for example, Luria showed in his research with people with brain damage, right? If certain areas of the brain are damaged, particularly language areas, the mental system begins to break down, okay? The process itself starts to break down. So that tells you that if you really want to understand the process, the explanation, that why the balloon expands, right? You need to get at this underlying, what are the elements, what's the relationship, and how do they relate to each other? Now, this example that I'm going to show you here is basically Vygotsky's argument that explains human consciousness, right? And I think this brings everything together in what I'm trying to say. So he says that humans are fundamentally animals and not animals at the same time, right? We share a certain mental capacity with higher animals, primates, and other forms of higher life, right? So every human being is born with essentially the same brain, assuming you don't have brain damage at birth, right? So every human being has an animal brain at birth. And that animal brain is comprised of various elements. And you see these elements: attention, imagination, emotion, perception, memory, intention to do things, right? But all of these things are not connected to each other. So these are the elements in the human animal, right? Children are born everywhere in the world with the same mental, biologically determined capacity as a consequence of evolution. But, he says, when language enters, that is, culture, through language enters, you get a completely new system emerges, because language connects all of these things together into human consciousness, a system that no other life species has, as far as we know. So what you see is, you see the elements here, and you see the connection of the elements, the arrangement of the elements, which gives us the human consciousness, human mental capacity, right? Now, there's many more connections here than I can show. If I put every connection in, you wouldn't be able to see the diagram. But basically, what happens is culture from our social reality enters the picture, right? It changes the relationship. Now, it's not causing in the sense of efficient cause, because if you take memory out, you're not going to have a human mind. If you take emotion out, you're not going to have a human mind, right? If you take perception out, whereas you can't see things, you can't perceive things, you're not going to have a human mind. So you need all of these components, but you need something that's going to pull them all together. And Vygotsky argued that it's culture through language. That's what gets us at the process. Okay? Okay. Now, Martin Packer has argued something similar. But Packer talks about what he calls constitutive experiments. That is, he recognizes that science, the social science in particular, right, cannot give reasonable explanations based on quantitative approaches that assume a linear causality, if X, then Y. Okay, so he's basically saying the same thing, right? But he's unwilling to give up the notion of causality being X equals, or X changes Y, right? So for him, that's the basic idea of causality, right? And then he calls these other kinds of things constitutive experiments. But I think for Tumala and for Vygotsky, They're not arguing against the relevance of quantitative research, because Vygotsky and Luria and all of the Russian psychologists they counted things, right? But they counted things that were countable, right? They didn't try to measure emotions. They didn't try to measure intellect. They didn't try to measure proficiency, right? They knew that those were problematic things to measure. But they counted people, they counted responses, and Luria's twins research and so on, they counted stuff, okay? So this is the experiment I just told you about that Galperin conducted in the Russian school districts, right? Where they left out external speech, right? Private speech, and you got an increase in errors and you got an incapacity to learn. But what's interesting, I want to point this out, there's a recent study that was done showing that some adults, for whatever reason, don't use private speech when they're thinking. The term that was coined to describe this was anendophasia. Okay, it's a fancy word, but it means you have a low frequency of private speech. And it turns out that adults who have this low level or absence of private speech have a really hard time doing memory tasks and doing other kinds of judgment tasks, like whether words rhyme or not. So it looks as if the element of language, if the element of language is missing, you're going to end up having problems in processing in a normal way that humans normally process. Okay? So Watson, this is 1934, he did a study comparing continental European psychology, which I abbreviate as CEP, and Anglo-American psychology in terms of how they go about doing psychological research, okay? And he saw that there were really significant differences between the two ways of doing psychology. So he saw that in Anglo-American psychology, it was assumed that individuals who scored the same on a given test had the same underlying process, right? So the assumption is if two people score 80, the process that they're using to score 80 is the same, right? They studied things like, and this is a problem, they study emotion, cognition, memory independently of each other. And psychology is still doing this today. And in fact, SLA is doing this today. Study emotion independent of intellect. Study cognition independent of memory. Study perception independent of emotion. Instead of seeing it as a system, this is why systems thinking matters, right? So if you study each of these things independently, you're not studying a human mind, because a human mind doesn't function only as memory, it doesn't function only as emotion. It functions as the unity of emotion, cognition, memory, perception, attention, as I showed you in the earlier slide. Okay? The Anglo-American approach was to use studies with large N's and sophisticated statistical procedures, right? This was the inheritance of David Hume and René Descartes into psychology, into social sciences and psychology in particular, right? And it assumes that in the individual mind can be understood by generalizations made over groups of individuals, right? So the idea is I study groups, and in studying groups, I can get at the individual mind. That makes absolutely no sense, right? Because you can have a group, as some recent research in neuroscience has shown, you can have a group mean that no individual in the group actually produces, right? And so what you end up with then is you end up with what Tumala calls a methods toolbox, right? And this, I think, is what Chen referred to earlier when he talked about people not questioning the tools that they're using to do corpus-based analysis, right? So most of the methods books that are available in psychology and in SLA, right, don't question the methods, don't question the techniques. they and, they train you how to use the methods. They train you how to use factor analysis and correlations and multivariate analysis and structural equation modeling and all of those fancy statistics, right? Without questioning why, right? And how do they relate to my theory? And do they get me at the underlying process that I'm interested in explaining, okay? And so this is the inheritance of post-World War II Anglo-American psychology. But Watson also points out that continental European psychology, of which Vygotsky was a representative, right, were more interested in qualitative descriptions and insights rather than objective scores on tests, right? They did correlations, they ran group studies, but that was only the beginning of the research, because they needed to examine individuals who didn't comply with the groups, right? So one of the things that often happens in quantitative research is you get a 60-40 split, let's say, as a result of a treatment. 60% of the people respond favorably to the treatment, 40% do not. The assumption is that, this is a good treatment to use, without explaining why the 40% didn't respond the way they responded, right? And if you're going to really understand the process, you have to understand that 40%. The outliers, if you think of it in terms of a bell curve, right? Outliers are often eliminated from quantitative studies. But for European psychology at the time, those were the interesting cases. What were the outliers doing that the other people weren't doing, or vice versa, right? Okay. So they paid attention to groups, but they were interested in the exceptions as well. And the exceptional behavior was necessary to really gain insight into what is going on in the human mind. Because remember, the goal of psychology, and SLA being really a sub-branch of psychology, is to understand the nature, the process involved in learning a second language, right? So you need to look at individual minds, what the individuals are doing, not what the groups are doing. The groups only at best can give you some guidance as to where to look, but it's really about the individual, right? What kind of person is the individual? What are the insights that I can gain from studying individuals? That's where the process is, right? That's where you're going to see the process. Okay. What's interesting in Ellis's 2021 paper, remember, where he looked at, I'm almost finished, where he looked at the different kinds of tests and what they would tell you about implicit versus explicit knowledge, right? He began the paper by saying, we need to draw inferences based on an individual's linguistic behavior. And he concluded the paper by commenting that, how is language represented in the minds of individual learners? But in between, what he was interested in was groups, right? Because he was engaged in doing quantitative research. And so he, in a sense, he was right to know that individuals are where you have to look, but he created a problem because he looked at groups to understand individuals. That's the problem with quantitative research. It doesn't get you at the individual, and it can't get you at the process, because it's only good at looking at the appearance of things, not the underlying process. Whether the variables are hidden or not, it's still looking at variables, not processes, not the elements, not the relationship, and not how the elements come together to form a whole. Okay? That's the problem. Okay. So I could mention there's two other studies that I've looked at, one of which is a patent study. I don't know if you're familiar with this, on Japanese word order, looking at UG. And let me just briefly mention this and then I'll stop. One of the things he looked at was whether English learners of Japanese could reset the parameter, because English is ahead initial language, Japanese is ahead final language, with SOV order, English is SVO order, right? And to make a long story short, without going into the details, he found that of 47 participants in the study, 9 of them supposedly reset the parameter. If I remember correctly, 18 of them partially reset the parameter, and another subset, I think it was 12 left over, didn't reset the parameter at all, right? Now, using ANOVA, quantitative statistics, the question is, why only 9 people? What does it mean for 18 people to partially reset a parameter? Why would they partially reset when 9 of them fully reset? And why would, from the same population, why would another 12 not reset it at all? That's what has to be explained, and that's what can't be explained through statistical analysis, right? You can describe something, but that's all based on appearance. It's based on scores on the tests, the test that Ben Patton and his colleague used to determine resetting. But what it can't do is get at the process that underlies that. Why did this particular pattern happen? Why some all the way, some partially, and some no way? That's what has to be explained if you're going to understand the process of second language acquisition. That's the problem, right? And something similar is done in Diwali's research with emotions that I won't talk about unless you want me to later. So that's the problem, okay? Quantitative research is useful, but it's only the start of the process of understanding and developing an explanation, right? It can tell you something about the appearances, the relationship between variables. It can't get at the underlying process. You need a separate kind of research. You need a different kind of experimentation, what Vygotsky called qualitative experimentation or constructive experimentation, where you actually try to build or modify the process, and in doing that, you understand the process. Okay, that's what I think causality is all about in SLA, and explanation is all about in SLA. It's not about quantification at all. And you can make the same argument about qualitative research. Narrative research also doesn't get you at the underlying process. So mixed methods doesn't solve the problem. Okay, and maybe we can talk about that if you have questions. All right, so I'll stop. Thank you.
Okay. Thank you so much. Thank you, Professor Nato, for this very thought-provoking lecture. We already have some questions from the audience. And at the end of the talk, you said you mentioned the emotion study, and a particular audience hope that you could talk more about the emotion studies.
Okay.
The Waleo 2026.
Okay. So one of the problems that I see, well, there are a number of problems. One is that the studies use Likert scales, right? Mm-hmm. And Likert scales are, first of all, ordinal scales, mm-hmm. but they're treated statistically as if they're interval scales. They're not interval scales. Yeah, so you don't know whether
Chris said this.
Sorry?
I once Chris said this. I once mentioned this in one of the live streams. Many of them, in my field too, they treat Likert scale as ratio data, which is not.
Yeah, it's not. It's not. A ratio is definitely not. I mean, that's just absolutely not, right? But even before you get to that, they haven't proven that emotions can be measured. How do you know that emotions can be measured? There's a psychologist named Joel Mitchell who's written splendidly a series of articles about why psychometrics is a pathological science. Mm-hmm. And it's because it just makes assumptions that you can measure almost anything without proving that something is in fact measurable and scalable, mm-hmm. right? Mm-hmm. So how do you know that emotions are measurable? Prove it before you even begin. That's sort of the first problem. But the second problem is, of course, using the Likert scale, because you don't know the difference. Is the difference between 2 and 3 the same as between 3 and 4? The distance, right? Is it the same? Do all participants have the same understanding of the scale, right? I mean, temperature, we all understand. right?
Yeah.
0 degrees Celsius is cold. Everybody agrees that that's cold, period, right?
Yeah, it's a very
And
very a legitimate question. Like different people may rank the same, if it is measurable, the same amount of anger by different number. For me,
yes, yes,
I'm out rigid, but for another
yeah,
person, it's just angry level 1.
that's right. Every time I go in the U.S. Medical system, every time you go to a doctor, and I'm having a problem with my wrist right now, right? So I have tendonitis, and I went to the doctor, and the nurse who checked me in asked me. They have a level 1 to 10 Likert scale for measuring pain, and she asked me, "What level pain do you feel?" And I said to her, "Oh, it hurts a little bit. I'm not really sure." And she didn't accept that. She said, "But what level is it?" I said, "But it sort of hurts a little bit. It doesn't hurt a lot." She said, "No, what level?" So I had to give her a number. So I picked the number 3, and then she was happy, right? I mean, it's just bizarre, right?
I will follow.
And
Okay, you
but
continue.
yeah, there are other problems with the studies on this particular study is interesting because one of the things they tried to do was to look at the correlation between positive attitudes in the classroom, right, measured on Likert scales, versus negative attitudes, things like anxiety. If someone has anxiety being in the classroom, or is bored being in the classroom, right? And they found that there were correlations between positive attitudes and its scores on achievement tests, right? But the problem is there were also people who had high anxiety but scored high in the achievement test. Now, how do you explain that? You can't conclude that positive emotions result in high achievement and negative emotions result in low achievement when in fact there are people with negative emotions scoring high on achievement. That's what you have to explain.
I think I belong to the second group. I'm always, I always have anxiety before exam, and I have anxiety all the time,
Right.
all the time.
Yeah, but you might score well in the exam.
No, I score okay.
Yeah. And also, there's a difference between anxiety and tension. Vygotsky makes this interesting distinction that says tension is a positive emotion because it can compel you to do something better. It's like, a pianist, a concert pianist, is sort of got a high level of tension before they perform, before an audience, which helps them perform better. So you need to be able to distinguish, again, these underlying processes of anxiety versus tension. Tension can be positive as opposed to negative. And so how do you know that what the students are reporting is in fact anxiety and not tension?
I think sometimes it's a naming issue. You call it by this name and then you define it.
Yes.
You
Yes.
give it a definition and then you study this definition, not the phenomenon itself.
Yes, that's the problem with operationalization. I mentioned that in my talk. That's the problem with operationalization. You get different researchers operationalizing variables in different ways. So there have been a couple of studies that have operationalized what they mean by private speech in very different ways. But the theory says private speech is this and it's not that. So that's the value of theory, right? One of the problems that I think both psychology and SLA faces is that it tries to use methods to unify the field, when in fact the field should be unified by theory.
Yeah.
It's theory that unifies science, not method. Right?
I agree.
And they make the assumption that any method can be used with any theory. That's not true.
No.
Right? That's not true, but that's the assumption. Right. And so what I think happens in graduate education programs is that students are pushed through courses in methods, but they're not pushed through courses in how to think like a scientist. That is the methodology side of it. And if They have a course in theory. It's just a survey of different theories of SLA, but it's not a course in how to think theoretically as a scientist. That's missing, right? So the field is dominated by method, not theory, and that's a problem. Right?
I will read some questions from the audience to you. One of the audience asks, "Dear Professor, I wonder if you mean we should research more about individual rather than quantitative relation."
Yes, and the answer to that is yes. But it doesn't mean that you should stop doing quantitative research. It means that quantitative research is only part of the process. You need to look at the people who are, you need to look at individuals at some point in your process, right? So you can say a group of people respond favorably to my treatment if I'm doing a pedagogical study. But you need to explain why, if you have a group of 1,000 people, why 400 of them aren't. And that means you have to look at the individuals. Yeah. And the other problem is that the problem of generalization. We assume that you can only generalize through statistical analysis with large N's. There's another way to generalize, which is what Vygotsky used, which is you have a good theory and you generalize to the theory. So your theory says, if I take private speech out of the process, development is going to be interfered with. That's what the theory says. So you do that. And you see, if you take private speech out, if the learner continues to develop, then there's something wrong with the theory. If the learner doesn't develop, then the theory is making a correct argument, right?
This is
that's the way you proceed.
Very similar to what Karl Popper would say. So the falsification of the scientific statement. You always start with a theory.
Yeah, you have to start with a theory. But you see, people who think they don't start with a theory actually start with a theory, because if you say, I'm not going to start a theory, but I'm going to study this group of people, you've already made a theoretical decision, right? I'm going to observe learners who are in this particular classroom, or people who have study abroad experience, or that's already a theoretical decision that you're making.
Yeah. I think I remember Karl Popper mentioned this in his book, the logic of scientific discovery. Yeah.
The only problem with Popper is his strong claims about falsification. That's I think challengeable. You don't want a situation where, and if you look at the history of science, there have been theories that have been falsified, but have been proven in the long run to be correct. So you have to be very careful.
Yeah, that's possible.
When you make claims about falsification, right? You don't do that easily.
I think following this question, I think why people favor statistics, why people love to study group. I think it's because it's useful in some way. They can make use of the results, the findings to do something, or to see some result. Specifically especially in business, in commercial world, you get these statistics from the population, and then you could target the customers, make targeting productions or advertisement. I remember. Sure. Yeah, there was a time like in 2000, like 10 years ago, people were everywhere talking about big data. They even claimed that causation is irrelevant. Only correlation is useful. As long as you could find a correlation and you can make use of the correlation and you can make money, nothing else matters.
Yeah. You're exactly right. That's what I was going to say. It makes sense in economics, in the business world, because if you have a group of 1,000 people that you study and 600 of them respond favorably, you can make money. Forget about the 400. The 600 going to buy your product, you'll make some money, right? But if nobody responds to your product, you're not going to make any money, huh?
But this is not the case in SOA. We want to help each individual, not just some people.
Yes, you have a responsibility to the people who don't respond favorably to the treatment. Why? How can I help them? That's what Vygotsky was interested in. That's why he had a clinic. He set up a clinic to study people who couldn't develop according to the normal ways of mediating people that a culture or society developed. How can I help these other people, these outliers, right? What we would call outliers develop. We can't leave them aside.
Outliers
We have to help
are
them.
usually discarded in quantitative analysis.
Yeah, that's right. It interferes. It introduces an error measurement, right, in my statistics.
So here's another question asking about the how does AI or large language model make us rethink our language learning?
Yeah, that's a good question. I'm on the fence about AI. I actually use it. I ask it questions. It's particularly good at helping me understand statistics. So I'm not a psychometrician, so I do use it. But I worry. What I worry about is that it will potentially undermine the development of individuals, right? So if everybody relies on AI to do the work for them, what happens to your own cognition, right? So I don't have to learn how to think. I just ask AI, and the AI thinks for me. That's a problem, right? But if we can use AI to compel people, to drive people to think in different ways, then that might be helpful. But if we use it as a replacement for my own mind, then we have to worry. That's a problem.
Yes.
Right.
So in your talk, you modeled the human mind as a network, connected or organized by through language, through culture, culture through language, of so many elements. But LMA may not make it in the same way. So do you think the AI can achieve the status of a human mind?
I've been following the research that's being done in neuroscience on consciousness, right? And to me, they're looking in the wrong place. They're looking inside the brain. And they're not looking, they're making an assumption, first of all, that language is a tool for communicating. It's not a tool for thinking, right? So it doesn't occur to them that language is what pulls all of these separate elements, separate components together into a unified system, right? So I think that's one of the problems. They're assuming that the answer is in the brain. Now, the brain matters, of course, because you can't think without a brain. You can't have consciousness without a brain. Whether you can construct a human mind, a real human mind in AI, I don't know. I mean, if they're going to do that, they have to figure out a way to get symbols, linguistic symbols, into the picture, right? So if you ask AI, "Are you intelligent?" they will tell you, "No, I'm not." The answer usually you get is, I don't have human intelligence, right? And the reason they don't have human intelligence, I think, is because they don't have the same kind of system that we have, right? It relies largely on all the information that's out there in the world that humans have created, right? And it tries to pull from that. So if you ask it, something like ChatGPT, really detailed questions about Vygotsky's theory, it's not very good. It gives you stuff that it finds out there, but if you ask it a general question, it's pretty okay. But if you ask a detailed question, then you're an expert in the theory, you can see that there are problems and there are holes in the way it thinks, right? So I think it can be an extremely useful tool.
Yes.
But to replace human thinking, I think it's a problem. Because remember, human thinking, the motivation for human thinking within Vygotsky's theory is emotion.
Mm-hmm.
We think for a motive.
Mm-hmm.
I'm not talking about, great emotions, but even slight emotions. I'm curious about something.
Mm-hmm.
I want to know. It satisfies me. That's an emotional impetus to find out something.
And also the cultures hinges on, the communication between people. It has to be enough number of individuals for cultures to form. But currently, the AI does not have a culture because all the chat tools we use, they come from the same source. There's only one brain or several big brains out there, but they cannot form a culture. But along this line, if we push it forward, when there are many robots, AI-driven robots on the street, and now there are a community of AI Autobots, they might form cultures. Then they have their own language, and then cultures through language, they have their own robot mind. Is that possible?
I mean, that's that sounds like something from science fiction, but I mean, I would be interested to see what would happen. Would you end up with a culture, or would you end up with a collection, right? Because the culture is a collective. Right? It's a collective where people perform different tasks, right? So the task I perform impact you, and your task impact me. But we're not all doing the same thing. If we all did the same thing, we wouldn't have a culture, right? We need people doing different things, contributing to a general process, right? And so on. So it depends on how the robots interact. If they interact and they all start doing the same thing, you're not going to get a culture. They have to be doing different things.
So this is very interesting because the AI, they are connected through internet. So actually they have only one brain. It's not like a human. There are 8 billion different brains that have different mind.
Different minds. That's
different minds.
Yeah. So maybe what we can do is have your AI teach my AI, and I don't have to learn anything.
So here's
send
another
my
question
AI
from
to school.
Another question from the audience. It's about the difference between implicit knowledge and explicit knowledge. And she asks, are morphological awareness and lexical chunks considered explicit knowledge or not?
It depends. It's going to depend on the history of where that knowledge comes from, right? So it's. I mean, I think when you learn your first language, if you look at some of the research that's been done in cognitive linguistics and usage-based linguistics, some of the work like Michael Tomasello and so on, you see that children learn lexical chunks implicitly. I think most of the evidence coming out of usage-based research, as far as I know, unlike in universal grammar research, Chomskyan research, is that people do learn chunks. And they learn them implicitly. They don't learn individual separate rules as you would in a Chomskyan view, but they learn chunks. Same thing with, now the lexicon is interesting because people, according to Paradis and Ullman, the lexicon is declarative knowledge. That is, it's explicit. You can tell people the words that you know, whether you're a linguist or not. You can start listing the words that you know. What you can't do, which is harder, is give them rules for a distribution, that is, for co-occurrence restrictions, right? So something like
strong T,
the double object constraint in English. You can't, people don't know that there's a rule that says that Latin-based terms, you can't invert indirect and direct object, for example, right? You can't say in English, donate me a book. You have to say, donate a book to me, supposedly, although there are dialects that do that. Right? Most people are not aware of that if you're a naive native speaker. So there are
But
limits.
they can use it correctly, right?
Yeah, right. But so the point is, you can't, to answer the question, you can't say that lexical chunks or any kind of grammatical chunk and lexical item is implicit or is explicit. You have to look at the history of it. My guess is, if we follow Paradis' argument, if you're a late learner, it's going to be explicit. Late learners would be people who begin learning language like in their early 20s, like most university students, right? And Paradis says that the procedural system which underlies implicit knowledge begins to decline first in the phonology. That's why most of us have accents when we speak second languages as adults, right? It declines in the phonology, then it spreads to the morphology, and the last one, I think, is the syntax. Pragmatics, I'm not sure of. That's probably more like lexical knowledge, although I'm not sure of that.
So you mentioned that in one of the studies, it's actually very difficult to distinguish the automated explicit knowledge and the explicit knowledge. So is it possible for Chinese learners of English, for them to automate their explicit knowledge of lexical chunk so that they could speak English fluently?
Yeah. Okay, my answer to this is going to be a little bit complex. De Keyser doesn't make a distinction between automated implicit and automated explicit. But Paradis says that the only kind of knowledge that we can have that's fully automatic is implicit knowledge of our first language. So implicit knowledge governed by the procedural memory system is what's automatic for him. Explicit knowledge is never automatic, but it can be accessed quickly. So there's a difference. So you might argue, and one of the ways of testing this would be to see what happens when you compare somebody who has quick access to explicit knowledge versus automatic implicit knowledge. You would think the automatic implicit knowledge would be quicker than accelerated access to explicit knowledge, right? But he says pragmatically, in terms of actual being able to function in the language, it doesn't matter, because you can function quite well with speeded up access to explicit knowledge. It's not automatic for him. For De Keyser, it's automatic. So there's a difference in terminology there and how they use the term automatic.
So that means even if you learn language in an explicit way, but if you could react fast enough, and the people who are in front of you cannot tell the difference between explicit knowledge.
I think that's how I speak. I speak two second languages.
Good news to the Chinese learner of English.
I think so. I speak Spanish and I speak German, both of which I speak with quick access to explicit knowledge. It's not the same as my ability to speak English, which is fully implicit, right? So when I speak Spanish or German, I can see the language in front of my eyes when I'm speaking it. I don't do that in English, right?
Yeah, it's similar.
So it's a different level.
With my speaking English, I have to think about what I'm going to say next.
Yes,
but I have
that's
to
exactly
think
right.
fast so that sounds fluent.
Yeah.
That's very interesting.
Yeah.
Here's another question. Okay, well, I think we have long overdue for the time. Just one last question from the audience. Cassie asked, would you recommend us to use more mixed method approaches?
No, I think mixed methods have the same problem as quantitative methods. They can't, studying somebody's narrative or interviews or asking them questions, asking them to introspect, for example, or whatever you do, is still not going to get at the underlying process. Right? So neither what we call qualitative research or what we call quantitative research is going to get us to the underlying process, how the watch is made, why the balloon expands, right? Am I using implicit knowledge or am I using explicit knowledge? We're not going to get at it through either qualitative research, mixed methods research, or quantitative research. We need a completely different kind of research paradigm, a different kind of thinking that's focused on the process. We need to get at the underlying process, and neither of those approaches will get us there.
Okay, so it's 10:15 now, and thank you again, Professor Lantov. Thank you for this very, very thought-provoking lecture, and I believe all the audience, just like me, we have learned a lot from this. And let's call it a day, and we hope we could see you again soon in our live streams. Next topic. Someone in the audience is already asking for the next topic. So could you talk about language and neurolinguistics next time? So they're asking.
All right,
for
let me
more.
think about it. Okay. Yeah.
Okay. Thank you again, and thank you for our audience for your time.
Yeah, and let me say I enjoyed your talk again. I think
thank
you're
you
onto
very
something
much.
there. It's really good. It's really done. Really nice. Take care. Bye-bye.
Take care. Bye-bye.
Bye. Bye.